Hello, my name is Joe Schmidl. Today I'm going to be explaining alternate space propulsion. In this video, I will explain what these alternate systems are, how they work, and why they are important. I will then explain where and when they will be used and who will be using them. The two main alternative propulsion systems I will be talking about are ion thrusters and solar sails. Both ion thrusters and solar sails lower the cost of space exploration. This is because they typically do not require traditional fuels that are used in today's spacecrafts. Ion thrusters and solar sails will still require a standard rocket to escape the Earth's atmosphere. This is because the Earth's escape velocity is greater than the thrust produced. I find ion thrusters interesting because they were first developed at the NASA Glenn Research Center in Cleveland. Ion propulsion, first developed there in the 1950s, has been widely used in satellites to keep themselves in orbit. Now that you know a little bit about ion thrusters, I will explain how they work.
In this video provided by NASA Jet Propulsion Laboratory, xenon gas is sent an electric charge. The ions are then sent through an electrically charged metal grate. The ions are shot out at 90,000 miles per hour. The individual ions create a pushback on the spacecraft, resulting in motion.
An ion is an atom that is electrically charged. This process of ionization electrically changes an atom by adding or removing an electron. Unlike typical chemical rockets that are limited to their thermal capability, an ion thruster's top speed is limited to the voltage applied to the ion optics. First step, find 9 quarters. Hold the quarters in your hand. This force is equivalent to the thrust produced by an ion thruster. Ion thrusters can produce 0.5 newtons, or 0.1 pounds of thrust. This results in an acceleration of 0 to 60 in 4 days, but over time can reach a speed up to 200,000 miles per hour. In this quiz, you'll be answering 5 questions, all about ion thrusters. Question 1. What is the top speed of a modern-day ion thruster? The correct answer is C, 200,000 miles per hour. Although they have slow acceleration, their speed is dependent on voltage supplied to the engine, which is technically unlimited. Question 2. What is the primary gas that becomes ionized? The correct answer is A, xenon. Xenon gas is used because it is inert. This eliminates the chances of an explosion. Other gases such as krypton and argon may also be used. Question 3. How many pounds of thrust can an ion thruster produce? The correct answer is D, 0.1 pounds of thrust, or 0.5 newtons. Question 4. True or false? Ion thrusters are safe because taking off from Earth, no combustion is needed. The answer is false. Combustion is not a byproduct, but the amount of thrust produced cannot escape the Earth's gravitational pull. Question 5. When were ion engines first created? The correct answer is B. The NASA Glenn Research Center began developing ion engines in the 1950s. The first operation in space occurred in 1964.
Solar sails work by using the sunlight to propel the spacecraft throughout space. Although sunlight has no mass, it does have momentum. Light that bounces off the reflective material causes motion. The sun can provide the craft with infinite amount of energy. Thoughts about a solar sail for space transportation was first conceived by Kepler. He observed comet tails that pointed away from the sun and believed it was the sun that caused this reaction. In 1976, Jet Propulsion Laboratories began to design the first solar sail. Its proposed mission was to study Halley's Comet. Because of the few moving parts and no propellant, solar sail spacecrafts have a low cost and extended operational lifespans. Just like ion thrusters, solar sails produce very little thrust. Depending on the size of the sail, around 5 newtons of force is produced. The sails are composed of ultra-thin, lightweight reflective material. Typically this material must be light enough to not affect the craft's momentum, but strong enough to fold up and deploy when it reaches space. Many organizations and companies all over the world are using these low-cost systems for space exploration. The Planetary Society is scheduled to launch a solar sail next year. It will hitch a ride on the SpaceX rocket. Ion thrusters will be used in an upcoming NASA mission to capture an asteroid and bring it back into the Earth's orbit for observation. In this quiz, you will be answering 5 questions all about solar sails. Question 1. Solar sails are ideal for... The answer is interplanetary travel. Although deep space is a possibility, momentum would need to be built up within the solar system to accelerate faster. What type of material is a sail made from? The answer is B, thin and reflective. Some advances are leading to developments that use nanotubes rather than mylar and aluminum. Question 3. True or false? The heavy mass of the sun's photons propel the solar sail. The answer is false. Sunlight has no mass, but it does contain momentum. This momentum pushes on the sail to produce motion. Question 4. What determines the speed and direction of travel? The answer is D, all of the above. The closer the craft is to the sun, the more sunlight affects it. Question 5. How long can a solar sail travel? A solar sail has an infinite amount of energy provided by the sun. However, as the distance from the sun increases, acceleration decreases. Bonus question. Who is the CEO of the Planetary Society? The answer is Bill Nye.
conclusion, the future of space exploration is near. These systems of travel once were just science fiction. Now we live in a time not only when they are a possibility, but being tested and used all the time. The cost savings provided by solar sails and ion thrusters will ensure our future generations are exploring the universe. If you have any questions, please feel free to comment. My name is Joe Schmidl, and this has been a presentation on alternate space propulsion.